Good evening, and welcome to the Museum of Science. I'm Lisa Monrose, producer of the Brainiac series here, and tonight we begin Global Warning, our new series on climate change. As you can note on the back of your programs, we are continuing the series in February and March, and we hope you'll be able to join us then. Tonight, our focus is on the legendary and intriguing North Pole. We are very pleased to have with us Andrew Revkin, one of America's most honored science writers. With many awards given to his books and articles, he has been covering climate change and climate politics for 20 years. And he was the first New York Times reporter to file stories and images from the North Pole. In the summer of 2003, Mr. Revkin traveled with a group of scientists who are trying to determine what's behind the dramatic warming of the Arctic climate. His new book, The North Pole Was Here, which he will be signing outside of the theater after the program, chronicles his trip and provides children and adults alike a chance to explore and learn about global warming. Please join me in welcoming Andrew Revkin.
Thanks for coming. Is this working? Am I on? I am on. Okay, well, I'm going to make this real fast-paced so we can have a lot of interaction once I'm done taking you to the North Pole. And you'll get to learn what this sign is about shortly. The tense changed from is to was. Well, I'll give you the heads up. Essentially, the ice that you're looking at there is floating on the Arctic Ocean. It's easy to forget that the North Pole is an ocean. And it's moving. The ice is moving like a giant turntable, about 400 yards an hour. So if you're at the North Pole right now, as these scientists were when they set up their camp, you after an hour or two or three, you're not there anymore. So after a day or so, they crossed out the is and put was. So I'm starting my story not in current time, but when I started getting familiar with the Arctic, I went back through our own clippings at the New York Times, which now actually anyone can do. They're all digitized now. They used to be in little brown envelopes and all crumbly. And lately, this year particularly, there's been a sense that this global warming issue is a breaking news story, something new and different. But when you go back through our clippings, you see that the climate has been in the news quite a bit. In fact, here in 1890, they were saying there was a real alarming sense in New York that something weird was happening because what they call the ice crop in the Hudson Valley had failed for 2 years in a row or something. The ice crop, for all those who weren't born 100 years ago, was we didn't always have refrigerators. You actually went out in the river in the depths of winter, hacked big blocks out of the river, put them on a sled, horses drew them into a barn, you covered them with sawdust or hay, and that was your refrigeration for through the summer. So there was no ice. They had to start importing ice from Norway. What's up with the climate? Something was up. 1932, look at this headline. Next great deluge forecast by science. Melting polar ice caps to raise the level of seas and flood the continents. Does that look familiar? Now, at this stage, in our understanding of climate, there was the idea that humans could be influencing the system eventually was just percolating. It wasn't really even fully born yet. But there was already, what we were seeing here was that scientists were learning about the big cycles of climate change through time. Ice ages and warm periods like the one we've been in for 12,000 years have come and gone, and that knowledge hasn't always been there. It's something that we learned about. And then, 1956, this story really got to me when I pulled this one out of our clips, because that's the year of my birth, among other things. I just started getting all my AARP mail for all of those. Anyone else just turned 50 recently? And here's a guy who I had never even heard about, Valdemar Kempfert, one of our first science writers at the Times, who had written a story already 50 years ago saying that carbon dioxide, this gas it's the same gas that you exhale, but it's the gas that's released when you burn fuel, like coal or oil, or if you burn a forest, was being released into the air, and that would eventually warm the world. And the last line in this story was particularly amazing to me, because I just recently wrote a long piece on energy technology options. What are the things that we need to do to get through this century with 9 billion people instead of 6.5 without really overheating the planet? We have lots of coal and oil. We can't. If we burn it all, we're in trouble. So what do we do? And one of the things that I wrote in that story was essentially the same line that he wrote 50 years ago. Coal and oil are still plentiful and cheap in many parts of the world, and there's every reason to believe that both will be consumed by industry so long as it pays to do so. What that really means is so long as it'll be consumed by us. Industry is kind of a proxy for society. And my journey to the Arctic started in a very different place. I went through school, high school, college, not intending to be a writer or a journalist. I really didn't have any journalistic bones in my body. I wanted to be a scientist. I grew up at the time when Jacques Cousteau was going around the world throwing a camera underwater and saying, ooh la la. And that was incredibly exciting to me, and it got me engaged with the idea of being a marine biologist. So when I got out of college, I grew up in Rhode Island, just down the road here, and I went to Brown, and I got out with a biology degree. I didn't head north. I headed to the tropics. I got a fellowship that allowed me to travel and study in the South Pacific, of all places. And then I hitchhiked a ride on a boat, this one. So again, you don't see any ice in these pictures, right? That was my realm for a long time, and I had to be forced north, as you'll see. And eventually, though, when I was out overseas, I was seeing things that really made me want to tell stories. And that's essentially what a reporter does. So I didn't really realize it, but I was kind of becoming a journalist when I was on that trip. And I got back to the real world. This is Los Angeles, which is not quite the real world, but that's the Los Angeles Times in the middle there, one of the first places I worked. And I started to write about that stuff, pollution, 20th century style pollution. One of the things that I try to convey to people, one of the reasons I think that the climate problem is a bigger one than what we faced 20, 30, 40 years ago, is that the pollution that we grew up with, my generation grew up with, was all kind of in your face. It was stuff you could smell. It was smog. It was sulfur dioxide that would cause acid rain right now. It was the Hudson River, where I now live, was full of raw sewage. These are all things that were very much a threat to your health and well-being in the present tense. Now, climate is not like that, and most of the issues that we're going to deal with, I think, in this century are much more subtle than that, and that's why they're harder to solve. You know, carbon dioxide is not like that stuff. It's the bubbles in beer. So how do you kind of build a groundswell of global action to stem the rising tide of emissions that are also the same stuff that seems so natural and inoffensive in other ways? 1988, another time when global warming started to become a story again, was when this picture was taken from the space shuttle circling over the Amazon basin. So what you see under the shuttle there, everything except those puffy clouds is smoke. The puffy cumulus towers are good old-fashioned thunderstorms. All that other white stuff was smoke because the Amazon was burning at an unprecedented pace. And also that summer, 1988, up here in the northern hemisphere, there was a scorching heat wave. So the media put this all together into a lot of powerful stories. We had burning forests, we had scorching heat, we had everything we needed to make a powerful story, images and pictures and a sense of the here and now. And right now it's kind of interesting. Looking back then, of course, it was all about burning tropics, and now it's all about melting poles, which is odd, but I'm not quite sure what that means. But remember, I'm a tropicophile, whatever that is. I'm oriented toward the tropics, so when I saw what was going on in the rainforest, that pulled me south instead of north. And the first book that I wrote was on the destruction of the Amazon rainforest around the edges and the life and death of Chico Mendes. And I spent 4 months running around in that area learning about what was causing this kind of change to the landscape. And finally, though, by the way, in 1992 or so, I wrote my first book on global warming, which was really a bad time to do that because Mount Pinatubo in the Philippines had erupted and sent a big giant cloud of sulfur particles, sulfates, way up into the stratosphere and cooled the Earth off for a few years. So my book on global warming, the first one came out right when the planet was actually cooling for a little while. Not a good marketing ploy. So that forced me kind of to look for a day job. And there was an opening at the local newspaper, this one. And so I'd started in my career mainly writing for magazines. I had one quick stint at the Los Angeles Times, but I really didn't get used to the rigors of newspaper journalism until I got here. And just to give you a sense of what it's like, when you first have to write a story on daily deadline, we have to turn it in right now. It's for the kids in the room, it's like when you have to write an essay in an hour. It's sort of the same thing. You got to get everything right. You have to spell the names right. Professor of what? All those questions have to be answered you have to explain what a greenhouse gas is, and you have to do that all by 6 o'clock. And I had one editor one day when I was writing one of my first very simple, boring stories, leaning over my shoulder, and I'm typing away. He says, "Revkin, this ain't no seed catalog." And thanks, I really needed that. And he was right. It's a big paper with a lot of influence. So that was 1995, and I started out writing about regional environmental issues around New York. And in 2000, I transitioned back to writing about things like global warming, which I had already been doing for other publications. And now it's been 6 or so years of that. I've written 250 stories, more than that now, on climate change since I started on that beat just 6 years ago at the New York Times. So it's become kind of my stock in trade, which is a little disturbing, but so be it. And now we're at this really weird juncture where our whole discourse about this, the whole conversation we're having in society about this issue has become totally polarized, so to speak. You have kind of a catastrophist element, like the Time magazine story I'm sure a lot of you saw last spring. Be worried, be very worried, it's happening now, it's a real-time emergency, which is similar to the Al Gore thesis. And then you have the Michael Crichtons of the world saying it's all hooey, and Senator Inhofe with him as well. And what gets lost in all of this, having covered this issue for so long, I've come to realize that this traditional way, if we just go for the headline, if you try to make it less complicated than it really is, and you just do that, you're missing something. And the more people try to make it sound alarming beyond what it really is, and it's a big challenge, and it's a momentous point we are at in human history. We're actually influencing a planet-scale system, but if we push the panic button that way, then that allows people like this to say, oh, they're just pushing a panic button. And what gets lost in all that is what we actually really know. And in the middle of all that, we know a lot. We know that carbon dioxide traps heat in the air. Even the skeptical scientists say, they agree, it's a greenhouse gas. If it wasn't in the air, we'd all be frozen in place right now. And you put more of it into the atmosphere, it will make the world warmer. So it's basically a very simple formula is the thing that no one disputes. More CO2, warmer world, less ice, higher seas, and a lot of climate change. And to me, that's kind of enough to get my attention. Now, maybe it's just because I've been so focused on this stuff for so long. And again, the other element that happens if you make it into sort of a catastrophic scenario beyond what science actually knows, then I think for young people particularly, that can be sort of a paralytic situation. So when I'm faced with all that stuff, besides just continuing to write about the science as it comes out, and I write about the politics, and I exposed, when someone was trying to prevent this NASA scientist, Jim Hansen, from speaking with the media, and I wrote last year about an oil lobbyist in the White House rewriting climate reports, and I do all that stuff too, but sometimes I get sick and tired of it, and I go to weird places. That's me, very far from the Beltway. This was a picture I took of myself in a microsecond of I don't know what. It was on the north slope of Alaska in December. 30 degrees below zero, about a 30-mile-an-hour wind. And I felt, I looked like Sasquatch meets Hannibal Lecter or something. And I kind of felt that way, too. So, and I was out there, though, not just to have fun. I was out there with scientists who were willing to tolerate those kinds of conditions to learn more. In the face of all that polarization in politics, there are scientists who are out there working their tails off in horrific conditions just to answer little questions, to make the picture slightly clearer of where we're headed. The tundra in Alaska, that Arctic part of Alaska, has been warming such that the frozen season in Alaska, that really hard frozen winter when you can drive big vehicles on the tundra to look for more oil, which is what we do in the winter up there, has shrunk in half from about 200 days a year to 100 days a year in the last 30 years. So there's been an enormous change. And these guys, Harry Bader and his partner, were out there banging a rod into the tundra just to get a sense of how hard it was, hour after hour. I just was so impressed with that. And this is Harry Bader in the middle of a horizontal ground blizzard leading a bulldozer around with his little headlamp there. And I snapped that picture. It was just one of those miracle pictures where you just kind of point the camera and shoot, of a guy, again, doing such a great public service in an invisible way. This is not Nobel Prize-winning science. This is the grunt work of science. But there are people out there doing this stuff, and I like to tell their story because people, I think, have forgotten about this aspect of science. that you actually have to do it. It's a doing thing. It's not a set of facts on a shelf that someone just takes down and hands to us. And I went to Greenland, which, again, all this was initially I was very reluctant about all this, being a creature of the tropics and liking skin diving and coral reefs. And I had to get out a Cabela's catalog. Anyone here get that catalog? It's about this thick. And there's a whole giant section on boots and outerwear. So when I went to Greenland, I had to rush to get some really heavy boots. And the only Sorels they had in stock had turkey camouflage on them. So I went to that ice sheet with turkey camouflage on my boots. I looked pretty silly. But I was there to understand more about what's happening with that giant hunk of ice. Greenland is just a 5-hour flight in a military propeller plane from where I live, from Albany, New York. You get in a plane and you get off and you're at the edge of the ice age. That cliff there is not a cliff. It's ice that's thousands of years old, crumbling in front of our face and sort of washing down as a stream of meltwater toward the sea. And it was an amazing experience to be standing at the edge of a hunk of ice. It's twice the size of California. It's 13,000 vertical feet of ice in the middle. It's essentially, it took me a day of working with atlases and things to figure out how much water is represented in that ice up on Greenland. And essentially, it's as if God came down and flash froze the Gulf of Mexico. For all you kids, think of that. Think of the Gulf of Mexico on your map. And you take that entire ocean, 3 dimensions, flash freeze it, and plunk it up on land like a pancake. That's how much water is locked in Greenland. So when scientists talk about the accelerating pace of Greenland melting, they're talking about a substantial issue. It's about 20 feet of sea level rise from Bali to Boston would happen if all that ice somehow slipped into the sea right away. And obviously, it won't happen that fast. It'll take centuries, most likely. But it's something to pay attention to. Finally, though, I've been to the Arctic. You have to go to the North Pole once you become enamored of the Arctic. There's something about the North Pole that truly is magnetic. And well, not that North Pole actually. The magnetic pole is over there. At any rate, you get the idea. And it's always been that way. When I started writing this book, I did a lot of reading about the history of the North Pole, and it started out as an idea. For thousands of years, humans had this notion of north. Something's up there. It's kind of colder, and the magnetic compass, when China invented the first magnetic compasses, they pointed north. So we had a sense of some place up there, and people became familiar with astronomy, and you had a sense that the world had a top and a bottom, and there was an axis, and it spun. But still, even as late as the mid-1800s, we had all these notions about the North Pole. Many oceanographers thought that there was an open polar sea, that if you got past all that ice that was killing people like Lord Franklin, freezing these ships in place, that it was actually quite nice. And then there was this magnetic mountain. That's what that pyramid is in the middle, Lodestone Mountain, that generated the magnetic field of the North Pole. So, of course, we've learned some things since then. And, by the way, the idea that Santa Claus spends his summers at the North Pole, no one had really speculated about that very much before the mid-1800s. And there was an artist named Thomas Nast who first proposed that Santa lives at the North Pole in the summer. And this was one of his early drawings of that. And by the way, well, you'll see in a minute. I saw some evidence. We'll see. So we've learned a lot since then. And science has really opened a lens on the Arctic that shows us there's enormous changes afoot. That blue and red area is the summertime extent of the sea ice that floats on that ocean up there. And that's like the average amount that's been there for decades. And then the summer of 2002, and actually even less, several years since then, it's pulled way back from the shores. All that kind of pinkish area around the continents is open water. And now computer simulations playing this forward, there's a significant prospect with more warming that the top of the world, for the first time in human history certainly, and perhaps tens of thousands of years and perhaps longer, will be a blue ocean in summers. And that, to me, also is a big deal. All the questions about the more dramatic questions don't seem any more dramatic than that to me. But there's a lot we still don't know. Oh, by the way, when that ice pulls back from the ocean, from the shores, it has consequences for anything that relies on seals. And polar bears, of course, do. Everything I've learned from the polar bear biologists I've been talking to for years now is that you shouldn't worry that they're going to go extinct. there's plenty of places around the Arctic where they'll be able to survive well through, probably well through into the 21st century and beyond. So you've probably heard some more dramatic tales there, too, about them being on the brink of extinction. It's not that simple. Finally, though, I did get a chance to go to the North Pole itself. There's this science team, as you'll see in a minute, that they've been trying to plug one of the other holes in our understanding of climate change. And we know a lot about the world. Satellites have revealed all kinds of things about the atmosphere and what levels of the atmosphere are doing in terms of warming. And the oceans themselves, you can plumb with buoys and things. But this ocean, you can't do that. The only data we've ever collected from the Arctic Ocean was nuclear submarines during the Cold War. They'd be under there, our submarines trying to find the Russian submarines and them trying to find us. And they collected some information on how thick the ice was, but that's about it. So finally, this team, the last 5 or 6 years, they get in a little airplane, not so little, a 15-ton airplane, and I got in with them finally. And you start flying north from the northernmost place in Canada, alert, and you fly north essentially until there is no more north. When you run out of north, that's the North Pole, and then you land. So we're landing this 15-ton airplane with normal rubber tires on the sea ice at the North Pole. This happens only in April. It's the only time when the ice is hard enough to land on, but not mushy on top because the sunlight's just beating down on it all summer. And Russians come out, and they make a little air base there on the floating ice. Everything you're looking at there is on ice that's about 6 feet thick on top of an ocean, including the bulldozer. It's really weird. And they do this for other reasons than just to help scientists, as you'll see in a second. So when we got to the Russian camp, and things got really weird in a hurry. And not just because of the guy in the red robe who was speaking Russian. And so, I don't know whether he was an imposter for the kids in the audience. Who knows? He looked like Santa Claus, but he also looks like Dumbledore. So, and he spoke Russian. So I don't know. I'm going to reserve judgment on whether we actually spotted Santa. But there was this woman from Russia who had, she was the runner-up in a beauty pageant, Mother Russia contest. And the winner had a chance to go to this tourist camp at the North Pole the Russians run, and the winner had turned it down, but she said, I'll go. And she did, and she brought out her gown and everything, and it was very strange. And we ate dinner in this, there was this weird cafeteria there that, because there were so many different kinds of people, there were Russian skydivers, millionaires, there were South Korean ski trekkers, there were kind of extreme sports fanatics. There was a marathon run at the North Pole this year, the year I went. And so everybody eats in this dining hall. It's kind of like the bar in the first Star Wars movie, the movie that I call the first Star Wars movie, the one that came out in 1977. Everyone's speaking different languages and also eating really weird food. This is what we dined on at the North Pole. And I was told that the years before, the French had run the commissary there, so the food was like nice wine and nice cheese and fruit. And we got there, and it was gulag food like this. It was really scary. But then you think that's all sort of feeling like a Fellini movie or something, but then the really weird stuff starts to happen. This, you remember, after you've been there for a few hours, that you're on an ocean and not on the tundra or something. And the way you remember that is that strange things start happening around you, like this. That crack, that nice rugged plywood bridge was put over, turned into this crack in a few hours. And it's all, kind of looks sort of normal. It looks like a stream in the woods or something. That water is 14,000 feet deep. So you don't want to slip. And I have some videos somewhere. I haven't digitized, I put it on DVD or anything yet, of that guy over there. He picked up a 2x4 about a minute after he was taking this, and he's kind of banging it on the edge of the ice. And I'm thinking, this is not a good idea. And now, none of this is happening quietly either. Now, for the folks up there, we're ready for the sound clip. Everything you're going to hear now is the sound of the sea ice under us, because for every one of these openings that's spreading as the ice moves, there's a ridge forming somewhere else where other ice is butting up against itself.
Things you can see from space, very
Just listen.
you can feel the chunk that we're on actually starting to fail a bit more. Probably hairline cracks up towards the helos there.
So does that mean we should back up?
No, not yet. You can always jump over a crack.
You can always jump over a crack, great. So everything you're hearing now is the ice, and it was much louder. And that would go on for 20 or 30 minutes, and then fade away. And the thing, all of this is interesting enough, but can you imagine trying to do science in a place like this? It's just kind of unthinkable to me. But that's what these guys are trying to do. It was a team from the University of Washington, and this was their little camp, which is that tourist camp was about 50 miles away from the North Pole, the actual geographic North Pole. This camp is about 30 miles away. And what they do is once a year they come there to drop instruments through the ice to basically to take the vital signs of the Arctic Ocean underneath. And I'll show you what that all entails. This is Jim Ossie, the same guy who was holding hands with Santa Claus there a little while ago. He's one of the, well, you'll see in a second what he does. But this is a hole that they melt down through about 8 feet thick ice here. And they drop the instruments down like this. And they invented this system. Basically, that's a cable of Kevlar line that's 2 miles long. Remember, the ocean's 2 miles deep. And the Arctic Ocean is layered. It's stratified, as they say. There's actually warmer water down deep and colder, fresher water up high. And the only way to get a portrait of what's going on in that ocean is to have instruments strung all the way up through that water column. And they had salinity meters and current meters and thermometers that would record for a year. And they drop that down and they pull it up. They come back, pull it up, and drop another one down. And it all sounds kind of easy in theory, but it's not easy at all. So what happens when we got there, they came and they triggered it to let go of the anchor and come floating up under the ice. And of course, we're on the other side of the ice, so the next thing, obviously, is to get the instruments out. It's like $200,000 worth of gear. And the way that happens is Jim Ossie, the guy who was dancing with Santa Claus, has to do this, which is not my idea of a good time. Remember, I'm a tropics kind of guy, so I did not join them in the underwater portion of this expedition. But they did take some pictures. This is a diver's eye view of going down under the North Pole, essentially. And this picture particularly just makes my hair prickle because and when he got back up, he was telling me how spooky it is. And he's a very hardened, seasoned kind of field worker, researcher, engineer guy. And every time he goes down to do this, and he did it again this year, he said it's the closest thing he can imagine to being in outer space. You're suspended in an ocean. The water, he said the water there is about 300-foot visibility. It's like being in Belize or something. But it's dark, obviously. And it's 14,000 feet deep, and the ice on top of you, of course, is moving. It must be the strangest experience. And then there's that tangle of lines and stuff. This year, it took them 42 minutes of diving to get that tangle of instruments up. But they do it every year. They're not going to get a Nobel Prize. It's, again, the unsung work of science what they're doing is kind of adding that one dot to a pointillist painting, which is our understanding of climate change. And you only really appreciate what's happening to the world on this issue of human influence on the climate if you look at the whole picture. You can't just look at tropical glaciers. You can't just look at ocean temperatures. You can't just look at hurricanes. You can't just look at any of these things. It's as they say, the body of evidence that leads you to a clear conclusion that humans are influencing the planet's climate now. And my job in all this ends up being relatively simple. I just taking pictures, taking video, staying up as long as I can, to observe as much as I can, and then going back to the North Pole Bureau, the New York Times North Pole Bureau, my tent, and filing my stories with a satellite telephone, which all the kids in here have no clue what dial-up is like. But this was satellite phone dial-up. It takes 45 minutes to transmit one picture at a low resolution. So it was a very aggravating form of journalism, but you do what you do. And finally, the ice, again, that ridge kept rising right near where the helicopters were parked, and you kind of get the sense that this is all transitory. Again, the North Pole was here, has more than one meaning to me. The reason I ended up naming the book that wasn't just because the ice is moving. It's because that North Pole of our history and our imagination, this idea of a frozen, untouched place beyond our influence, is clearly becoming history now. Henceforth, the Arctic is essentially potentially what we choose to make it. And that actually goes for the world as a whole. We're at this amazing point in our history as a species when we were always local. It was always about the village. When we would fish in one lake, we would pollute one river, we would chop down one forest, and now we are influencing global systems. And I think it's a new idea for us. I think we have to kind of forgive ourselves and not be so shame on you about this. That it's a big idea to sort of get across that we have our hand on planetary scale systems, and now we're also poised to go from 6 to 9 billion of us in the next 50 years. Right now, there's 1.2 billion people on this planet who are between the ages of 10 and 19. There's 1.2 billion teenagers on this planet. That's an interesting thought. And it means, again, we have to pay attention that we're on trajectories that could lead us to some really big changes, or we could modulate our behavior and find a new way forward that I think is totally doable. I think there's been too much gloom and doom, and I think it's time to look at this century as a time of opportunity, especially for young people who could actually change their careers or sort of shape their careers to attack aspects of this challenge. And clearly people need energy. The woman there represents 2 billion people on this planet right now who cook their daily meals on wood or dung in an indoor fire that pollutes their house and kills about 1.5 million people a year. And they would love fossil fuels. They would love a microwave. They would love all the things that we have and take for granted. So who's to say they shouldn't have that? So without some technological breakthroughs that can allow them to get the energy they need to advance, the world is headed in a troubling direction. And I'll leave the rest. There's much more to say, but I want to make sure we get some time in for Q&A. So I do want to say, though, that I've been focusing my own attention much more on young people. Especially a year ago, I went to the climate treaty talks in Montreal, where I took that picture of those are our senior climate negotiators over there. And my impression now in looking at that picture is they look kind of constipated. They had, what their orders were? The guy on the right, his title is Senior Climate Negotiator, and his marching orders there were not to negotiate. And that was the same in Nairobi just 2 weeks ago. They're not allowed to progress. So that's troubling. And the people who were most energized at those meetings were young people. And they have a website, itsgettinghotinhere.org, which I recommend people explore. And that's why I chose to write this book for everybody who's involved here. We're essentially handing off a climate to our children and grandchildren. So that's my story for the moment. And thank you for listening. And I guess we'll transition over to some questions and conversation. And you can always reach me very easily. I'm like one of the most easily reached people in the world. So revkin@nytimes.com. Thank you.
Our next guest is familiar to many of you. Former journalist with the New York Times, former WGBH Boston Evening News anchor, current fellow at the Berkman Center for Internet and Society at Harvard Law School, and American media personality, Christopher Lydon is probably best known for his work in radio. His current production, Open Source, pushes the envelope of what a radio show is by integrating the internet and the airwaves, encouraging interactive conversation between Mr. Lydon, his guests, and his listeners from around the globe, which now include about 125 countries. So please welcome Christopher Lydon in conversation with Andy Revkin.
Good evening, and thank you. I'm just privileged like you to be here, and Andy doesn't need me, you don't need me, but I'm sort of straight man among us all. I'm a big believer, even at the New York Times, that the readers know more than the reporters do in a certain, not more than Andy exactly, but I just want to get a sense of where we are. You spoke of Senator Imhoff, who thinks global warming is a hoax. And we know Al Gore thinks it's a clear and present danger. Show of hands here, how many people would put their own kind of personal and scientific, intuitive anxiety level in the very low, say 1 to 3 zone? Show of hands. Sort of, this too shall pass.
They're not worried.
They're not worried. It's kind of like Red Sox, or How many would put it in the 4? I see one hand for the 1 to 3 zone. How many would put it in the? Out of 1 to 10. I'm looking for people who would rather dismiss it in the 1 to 3 zone. How many people would bid more in the 4 to 7 zone of pretty serious? How many would put it in the almost red alert 8 to 10 or above? Okay, that's interesting. Most people in the temperate zone, or more, or maybe a plurality in the temperate zone, but okay. I would just ask you, Andy, for starters, and then I'm going to throw it wide open to all the wise people in the room. Hammer this point that we're still kind of, as you said, getting our heads around, that we're not talking about pollution. We're not talking about dirty air or water. We're talking about something almost entirely different.
Sure. Well, again, at least for people my age, the things that we grew up with that mattered and that we created a whole environmental movement over, that Republican and Democratic lawmakers passed laws without big arguments over. We're all right in your
Richard
face.
Nixon was a hero.
Richard Nixon, he created the EPA, Endangered Species Act, Clean Water Act, Clean Air Act, all happened in that era. And but I think the reason that it was fairly easy was it was all in your face. It was kind of there, and by the way, we had the tools to fix it. You had big construction projects for sewage plants, and everyone likes that. Industry likes that because they get to pour the concrete. Unions like that because they get the jobs. And the river likes that because it gets cleaner. So, and then with cars, we put in catalytic converters, and all that was kind of doable. And now we're in the realm of the gas, that you can't avoid generating this gas when you burn coal or oil or natural gas. Natural gas is better, but the other two are really bad. We get more than half of our electricity from coal, and we're using more and more electricity. So and that's such a given. It's such a given. Someone was telling me that to invent a new system to do what we now derive from coal, to get electricity out of the socket, to put on a light bulb, he said it's not even like a moonshot, which some people have said we have to have kind of a moon Apollo program. It's like trying to invent a new way to go to the moon when Southwest Airlines is already flying there handing out peanuts. That's the challenge that we face in trying to reinvent our energy system, because it already works. It already works except for this little detail that these greenhouse gases build in the air and will create a long-term problem.
I'm just intrigued that we don't know what to make of this story. It goes back, when was the first New York Times story on climate change?
Well, the scientists first theorized that this was possible in 1896. Okay.
So what was the trigger moment of what we'll call the Al Gore consciousness, that something is dreadfully real, man-made, a kind of potentially terminal threat?
You mean recently? What has
when did it become a kind of? When did we enter this modern thing? I'm trying as a citizen to grapple with our confusion about it, our uncertainty about it, the Michael Crichton Al Gore gap.
And I think a couple of things happened. As I said, in the late 80s, there was a little bit of this, but I think now we're definitely in a more, there's more going on now. Partially, the science has congealed a lot. We really know a lot now. In 1988, it was mostly speculative. When I first interviewed Jim Hansen back in 1988 about this issue in that hot summer, he was talking about the roll of the dice. He said, we're loading the dice toward having a higher chance of a hot summer, a higher chance of a drought, a higher chance of a stronger hurricane. And now he's saying that the odds have actually played out. We are seeing a higher chance of these things. So that actually has, there's momentum to science. There's a trajectory to our understanding. We've really advanced a lot. And then on top of that, you have Katrina and high oil prices. I think those are the two things that suddenly jerk this issue into the foreground.
Where do you, I'm always fascinated by where the New York Times leads us, not only as a lifetime reader, sometime employee. What would you say is the Times' mandate to you? What does the Times expect from you? And I'm thinking of the Times as a sort of the mythical grown-up in our society, which is kind of doesn't know everything, but is in touch with the big stories. What do we think? What is the Times saying to us?
It's still pretty unexcited about this. And I think we all, in a way, there's been this burst of attention. I was struck by something that Justice Scalia said on Wednesday when global warming there was the first case involving global warming was argued before the Supreme Court by Massachusetts, the Deputy Attorney General. And there was this moment when the Attorney General said something about Scalia mixed up the stratosphere and the troposphere. And Scalia said, troposphere, whatever. I told you I'm not a scientist. That's why I don't really want to deal with this global warming thing. Now, and it's very quick. It's very easy to demonize Scalia over what he said, but I think a little chunk of all of us feel that same way. It's complicated. There's uncertainty. It's science. That stuff. That you just
all that hard stuff in school.
Yeah, it's hard stuff. It's physics. It's when you really look at the details of why this is a problem, it's because carbon dioxide lives a long time once you pump it in the atmosphere. And as soon as you get into explaining all that stuff, you're going through verbiage and jumps of logic that are complicated. It's not it's not an A equals B. So when I saw that from Scalia, frankly, I've seen that same reaction in my editors, not in the science section, mind you, but the bigger editors of the paper, for sure. They still kind of glaze over, and they're still intimidated by it, and they still don't see it as a news story because it doesn't have a here and now peg.
What do we do about that? I mean, it's such a familiar problem, it seems to me, in our world today. Who do we expect to teach us? Who is your grown-up on this subject?
I have a list of scientists who I consult all the time who are kind of my grown-up. And some of them are people I don't quote in the paper. They're just people that...
I'd love to know who they are. I mean, never
my
ask
Greek
a
chorus.
reporter's sources, but...
Well, let me think about that. Richard Alley at Penn State is a glaciologist he's one of the ones who went up on Greenland and poked a big hole in it. And we learned a huge amount from the ice cores that he pulled out of Greenland. He's somebody. Who else?
Do you know Jim McCarthy at Harvard?
Jim McCarthy is complicated. Is he here? Actually, I think he might be coming on Sunday. I'm talking at Harvard on Sunday. He's not on my A list, but I don't mean that to demean him.
Okay. Ed Wilson. I mean,
for biology, Ed Wilson for sure, yeah, but not for climate. One of the things that's really exasperating about this issue, the other aspect of it that makes even scientists kind of recoil from it, is it's so multidisciplinary. You can't just be a physicist anymore and really understand this issue. You can't just be a glaciologist and understand it. You can't just be a biologist, for sure. And because all those elements are kind of interlinked and have interplays that actually determine how the other courses of events play out. So there's a whole multidisciplinary form of science that's slowly emerging, even just to study this problem and how to fix it.
I'm getting more and more scared, I have to tell you.
Sorry.
I'd love everybody in the room to feel invited to just join the conversation. Put your hand up. And I don't think in this small space we need mics.
Just for the recording.
Sure. Monica will put you into history here with a microphone.
Hi, enjoyed your speech very much. One of the concerns that the complexity of the multidisciplines that have to deal with this issue is sort of layered on top of the complexity of all of the different societies in the world. In 2003, I was at the Three Gorges Dam, and to see that the Yangtze River, being raised 600 feet by a world where you have the women sitting in homes where they have no electricity, so this is the way of their being able to generate electricity. Would you sort of talk about that additional level of complexity that we have of all the different drivers in all of these different societies and the rights and needs of the people in those societies, given first world countries that have had them for so many years?
That affects the situation in several ways. One is most of the scientists who are charting a course into the future, a policy course, how do we actually fix this, see two courses. One has to allow developing countries to use more energy and have a lot more emissions. Basically, we have to work that much harder in richer countries to cut our releases of these gases so that they have the ability and they have the right to develop. And the only way you would ever get a consensus for how to move forward between poor countries and rich countries is for us essentially to do more work. The other way through this bottleneck is the focus of the story that I did, a long piece in the Times 2 or 3 weeks ago. We have this really interesting series that's been running all year called the Energy Challenge, And it's all on the web, nytimes.com/energy challenge. And I did a piece on the technology question, as I said a little while ago. And without a really aggressive burst of new research and development of energy options, well, let me frame it in a positive way. We need a really big research and development effort, including right from the educational system on up through both the public and private money, to make energy, finding ample sources of energy that don't release pollution, a keystone priority of this century. And because it matters far beyond climate. It matters in terms of development of the poorest in the world. It matters in terms of ending oil dependence so that we don't have conflicts over energy, which is where we've been for a while. So you have this 3 or 4-pronged kind of win if you really aggressively attack that energy problem. But as we wrote in that piece, our energy research budget in this country had one little blip in the oil crisis of the 70s, and it's been down ever since. And all of our other scientific research enterprises have been up, up, up. Healthcare has gone up, of course. We care about health. Remember, it's a here and now thing. But we haven't expressed that we care a lot about energy yet, which is weird considering how focused we all have been on energy this last year or so.
Interesting.
Energy.
I'll get to that in a minute.
Please.
I hear a lot about the producers of CO2, but I'm kind of interested in the consuming side. And I was pleased to see you had something about the rainforest, and I'd like to know what your thoughts are about those things, whether it's oceans that consume carbon dioxide
Sure.
or large regions like the rainforest, and what impact that might have on the whole balance of nature.
Well, one of the new threads in this whole puzzle is it's not just a climate problem. As I wrote a couple of years ago, and the New Yorker had a long story this week, the oceans are absorbing a lot of this carbon dioxide. Most of it goes into the oceans naturally. That's just what happens. The air passes the CO2 into the ocean, and it changes the pH of the ocean. They're not acid. They're still alkaline, but they're getting less and less alkaline. And that can affect the ability of clams to make their shells and corals, and could have very large effects if the buildup happens at the pace that's anticipated. So there are these direct effects. Now, the good news is that the oceans absorb a lot of CO2. In fact, the oceans and forests, half of the carbon dioxide we release every year gets sucked up by nature. And that can be tweaked. If you plant more forests, you can actually absorb more CO2 and blunt the buildup of the gas in the atmosphere. So nature can be our friend. In the oceans, it can create new problems potentially.
Did somebody ask about your view on nuclear power?
Yes. Well, I live 7 miles from Indian Point, this nuclear power plant near New York, and my wife is stridently anti-nuclear, and I'm more. I'm not agnostic.
Does that mean she beats you up about it, or is she out?
We have discussions, and actually, her car has a bumper sticker, and I have to kind of, I'm a reporter. I'm not supposed to take positions, so when I drive her car, I kind of duck. But no, it's a real paradox for people who care about climate. If you take nuclear off the table and say it's not an option, then you greatly amplify the energy challenge that we confront. But at the same time, if you say nuclear is the answer, then your job, whoever you are, Mr. or Mrs. Pro-Nuclear, is to find out how we can build 800 nuclear power plants between now and 2050 on a planet that builds 2 or 3 every decade. We would have to do that just to avoid having to build 1,000 conventional coal-fired power plants. So how do you?
But how many people know that? I mean, there's at least 100 coal-fired generators on the drawing board now, licensed. I believe in the Bush administration.
Oh, sure. And Texas has just started a new program. China's commissioning about 1 new coal-fired power plant a week. Yeah. And so coal is a huge thing to overcome. As I said, it's this big, cheap, abundant resource, unlike oil. It's there long enough that we could turn some of it into something like oil. And that, if that happens without trying to capture the gas or something, then we're really in a fix. And again, if you take nuclear off the table, it just means you have a bigger task.
Thank you. This is a great discussion, and I have lots of questions, but I'll focus on one. I think people will respond when we have feedback, and I'm wondering what it might take for the New York Times to publish daily a report, like a weather report, but daily kilowatt hours used in a specified region. So we see on a daily basis what our collective energy use is so that we get some feedback.
It's funny you should mention that. We have part of our Energy Challenge series, which is not just a one-year series. It's basically going to be a new component of what we do from here on in. We're doing a new website. It hasn't gotten up and running yet. That will have a lot of that. It will have trends and show you prices of energy, sources, what prospects are for all those things you're talking about. And Matt Wald, one of my colleagues who writes a ton about energy, he just has a story that's not come into the paper yet because they're still developing the web component that essentially looks at your life and says, here's where you can make the biggest differences. And it's actually got some non-obvious findings. You think light bulbs matter a lot, but we actually don't have our lights on most of the day. And driving matters a lot. And if you drive less, you really are making a big difference. And by the way, flying somewhere and driving there in a single occupant vehicle is about the same in terms of your personal greenhouse gas emissions, which is kind of interesting. So it'll have a lot
one
of
person in a 747?
One person in a car going 500 miles it releases the same per capita carbon dioxide as one passenger in a commercial plane because there's 200 of you or whatever.
But I think media has a responsibility to share that kind of feedback.
Yeah.
On a daily basis.
Well, a daily basis, I don't know. I mean, it gets challenging. We do it with the stock market for sure, obviously.
Right.
So if you're talking about like a carbon dioxide meter, meaning we've generated that much more each day, those are usually sort of fantasy anyway. They're not actually like in Times Square. There's a national debt meter that just ticks away. It's not actually the national debt, but. So we would have to have it grounded in some real data source, and that can be challenging on a day-to-day basis.
But that's a very interesting idea, something like a Dow Jones.
Well, ISO New England, for instance.
Well, yeah, well, send me an email.
Okay.
No, seriously, and I can, this is still in development, so sure, anything's possible.
Terrific idea.
Other questions? By the way, while we're at it, I'm going to go to our website. I think I can get online. So keep talking.
I'm just curious what you think some of the solutions might be in terms of coming up with alternative energy sources. Do you think it has to be a big government-sponsored effort, or do you think it can be done by private industry?
Oh, boy. Well, the story that I wrote said, and it has to be true because I wrote it, that there is not a lot of evidence that the private sector thinks far enough ahead. When they invest, actually, if you look at private investment, actually, I could show you. When you look at private investment, budgets falling in race to fight global warming. Where's our graphic? Essentially, the private sector has been investing less and less in long-term energy R&D, far less than the government. It's going down, down, down. And the reason is Wall Street demands profits now. And venture capitalists only invest even the most gutsy venture capitalists, those guys, the sort of the real aggressive investors, they're looking for a 5-year payback. And the problems that we face require much more sustained research on issues that are like the next generation of solar power. And if you're only working on a 2 or 3 year basis to get your payoff, then you're not really working on a revolution. You're just working on sort of the thing that's close. And we need the thing that's close, but we need the thing that comes next, too. And that's where the big gap is.
Fascinating.
I'll show you the graph. So this is like 1960 through 2006. And this dark line is private investment in research on energy. It went up during the oil crisis, and look where it is now, down, down, down. And that it goes against everything you've been reading lately. But a lot of what you've been reading lately about venture capitalists and is about biofuels, the green growing gasoline, which doesn't necessarily solve the climate problem. Anyway,
please.
Are there climate models which predicts if we don't do anything, when is the time of no return? So give it there may be 5 models, but what is the shortest or the quickest time frame when there's time of no return?
Well, we're already experiencing the warming is already in the pipeline.
But is there a scientific model where people doing modeling can come up and say, okay, if we do the same thing in 25 years, you reach a time of no return, things like that?
It's not that. That's part of the problem. The scenarios range so widely that there's no commonly held sense of where that threshold might be. And there's so many unknowns out there that could create feedbacks or responses in nature that could actually amplify warming, that you can't really have any confidence in any of those projections about when we're past the threshold. We may have passed it already. We don't know. We may not have. There may be feedbacks that cool things in a way that we haven't anticipated. So by the way, that comes back to a really important point, I think. And actually, just today, I was on the phone with Dan Schrag from Harvard, who he's preaching the gospel of we need to change the way we think about this from being a problem that you fix to being a risk that you manage. And we manage risks every day in life. It's a hedging thing. You buy insurance not because you know your house is going to burn down. You buy insurance to avoid that catastrophe, the financial catastrophe that would happen if it did burn down. And he feels, and I actually agree with him completely, that if we start to reframe our thinking and not worry so much about can we really figure out where that threshold is that we can avoid, then we're on the path toward getting through this in a way that's workable. I know. I know. But if it's not there, it's not there.
You've been talking a lot about the here and now, and just this has been on my mind a lot, especially recently, and I think there's nothing more here and now than the fact that it's like 60 degrees out right now.
Yeah.
It's on December 1st. And I want to know like how much this can be ascribed to global warming, or maybe it's just like some kind of divine coincidence.
It's kind of like a probabilistic issue. Again, there's probably an element of the weather we see around the nation right now that's related to this, but you couldn't articulate it very well because most of the computer simulations, even that we use to understand how the climate system behaves, can't deal with the scale of a state. They can't even deal with the scale, many of them, of a continent. They can't represent the Sierra Nevada mountains in a computer simulation, so you don't know whether, how that's going to play out. So it's really hard on the local level and on the level of weather. It's almost impossible to say, "Aha, this is it." It feels like it. But if you're in Chicago right now, you wouldn't say that.
I know, we get big storms.
By the way, that gets to another, I think, I've been thinking a lot about this paradox of why we haven't built a groundswell of, momentum in this country about this issue. I think part of it is we're such a broad, geographically spread out country that we don't have a common climate. The Northwest has had epic floods, and we've had warmth. We haven't had a frost in the Hudson Valley yet, and in the Midwest, it's cold and snowy, and so there's no common sense of peril. Even Katrina really affected a fairly small part of the country, and so I think that might be part of it, too. We don't have this common momentum on the issue.
I think people find it way too comfortable as well. All I hear
is
the warm
weather.
Nice out. It's so nice.
Yeah, maybe that's part of it, too.
If we're global cooling, it'd be another issue.
Yeah, that's true.
But meantime, how do we deal with the political interest in denial? There is a human reflex, and there's also a power interest and a money interest.
Easy. It's really easy. The dynamic that would change that completely is if the 4 out of 5 people below the age of 30 who don't vote regularly start voting and make this an issue that they demand politicians pay attention to. It's their climate we're shaping. It's not your climate or my climate. None of the things that are happening right now, the emissions and the solutions, are going to change my life. You realize that. This is all about 20, 30, 40, 50, 60 years in the future, including the solutions, because it takes so long to change an energy system over. We're not going to go to all solar tomorrow. So it's all about the future. And what it really comes down to in the end all, is how much do we, us, the empowered, older people, now value the future that we hand to our successors. And if our successors get more exercised about this, then there's a better chance of that dynamic playing out appropriately.
Please.
So one of the things you pointed out with your Southwest...
I like the picture of father and son here. Right?
Yeah.
One of the things you pointed out in your Southwest Airlines analogy was one of the challenges of how to get people motivated in an era in which energy is still relatively cheap, or at least it's available. But I think, to me, one of the frustrations of this whole, of why it's been so hard to get people motivated, is that it seems like there's an opportunity because it's not just the carbon dioxide issue. It's the fact that by coming up with a new solution, you can fix multiple problems.
Absolutely.
It's carbon dioxide. It's the fact that fossil fuels are becoming extinct or will be. It's this issue that we could come up with a new technology that would give us the next internet or something that could boost the economy, and we can get rid of our dependence on foreign fuels, which are obviously contributing to a lot of problems. And so with one solution, you can fix multiple problems potentially. It seems like it's rare that you can get that kind of convergence, and it seems like that should be something that can motivate people, but yet it hasn't. And I just wondered if you had any thoughts on how we can change that.
All it takes is one leader to have the guts to say no to the energy lobbies. That's it. That's it. And just stand up and say, this is our energy century. I could write the speech right now for somebody that would be, we are the can-do nation. We've done this before. We went to the moon. We blah, blah, blah. And FDR did it during World War I. And we can turn things around. We are innovative. We're brilliant. We have all these young people who are, hopefully can become adept at science. And we can make this our challenge for the century. And actually, this story that I wrote here, which it really does encapsulate a lot of my thinking on it. Get rid of the ad. We can't get rid of ads, though, otherwise we'll go out of business. That would be bad. There's a really good quote in here from a scientist named Marty Hoffert, who's an NYU physicist, who's been thinking about this stuff for decades. And somewhere down here at the bottom, he says that essentially it's like Kennedy made a speech that in '62 at Rice University that was essentially the speech that someone could make on climate. And what he said at that time was, we're going to go to the moon, not because it's easy, but because it's hard. Yeah, here we go. Right. We take on these challenges not because they are easy, but because they are hard. Hard. Yeah. Sorry. Hard. Yeah. Thank you. So it is. It's someone has to kind of step out in front and do that. And as you say, no one has done that yet. And I think maybe if there's some more engagement of the public along these lines, that maybe someone would figure it out. Lead the horse to water.
On a little broader issue here, not curtailing the importance that we all understand that our actions and our energy policies are polluting our environment, that we're escalating global warming. I was curious of whether scientists feel that even if we come to some type of solution to stop our pollution, to maybe put a reduction on the global warming situation, could it all be in vain that maybe nature has a cycle that no matter what we do, this may be part of nature's cycle to go through a warming and a cooling? I know I have heard in the past that one of the reasons given for the demise of dinosaurs and living plants in that time period was there was a global warming, that it affected the temperature of the ocean. The ocean got warmer, released more sulfur dioxide that polluted the air.
Sure.
The air. And that killed off breathing animals. And we know we can't control nature. It's very, very strong and powerful. With all our efforts to reduce our involvement in escalating this problem, is it an inevitable problem that will come about inevitably? What do scientists feel about this?
Sure. Well, all the climatologists who study this recognize the natural cycles of warming and cooling on every time scale, and there probably are aspects of the climate system that we don't understand yet, especially in the oceans, that can make things wiggle. The oceans actually got cooler the last year or two, the top levels. No one really has figured that one out yet because it goes against the clear trend temporarily. But again, I guess this gets back to the gentleman's his point that there's multiple reasons to pursue non-polluting energy alternatives for this century that are still something that would be great to do, even if it turns out climate isn't our fault, that the climate warming isn't our fault. So it's a hedge. It's an investment against the worst case. And in this case, the investment probably has a big upside potential as well, so why not pursue it regardless?
Good question. Thank you.
Yeah.
I just want to go back to your earlier comment. Thank you very much for your time tonight. The comment about, it just takes, one politician or just the youth of the future here, and the comment about how in the U.S. we can do this. But I want to go back and look at this as it's called global warming. This isn't a U.S. issue. It's a global issue. And can you comment a bit on the international interest? This week in France, several ski competitions were canceled.
Right.
There's no snow.
Right.
I grew up in Canada. This is a U.S. problem. We have hydroelectricity. We don't burn coal. But the North Pole's closer to Canada. They might flood first.
Yeah, sure.
India has a lot of people who need energy, but they're burning. They must have more than 10 to 1 person who don't use clean energy right now.
Well, there's several layers to that question, and it's a good one. One is that in all of our past treaties on environmental issues, like the Montreal Protocol, where we banished the things hurting the ozone layer, the developed countries of the world agreed to step first because we had created the problem. Right now, like with the greenhouse gas burden that's already in the atmosphere was created, 90% of that is the result of the industrialization of us and Europe. So there's an obligation, a commonly accepted one already, that we are obligated to kind of step first and give the third world a chance to move toward first world kind of, or at least out of utter poverty. But it's... Well, Europe already uses energy more carefully than we do, but they also are much smaller geographically, so it doesn't take as much energy to run their economy as it does ours. You don't have to send things long distances like we do. So they have some inherent advantages. And they're facing the same stresses now, though. Germany is opening up new coal-fired power plants. The UK is taking coal-fired power plants out of mothballs that they turned off because they had all this natural gas coming out of the North Sea, but they're going back to coal, too. So it's an issue for everyone. And you're right. I mean, the bottom. I think the other transition. I talked about us as a species having grown up locally. Part of the recognition of being a global influence also is the recognition that we all really are on this little marble in space. We really all are in the same village in the end. And as that kind of awareness spreads, and the internet is making it happen too. When I picked up the phone to fix my Dell computer, I'm talking to someone in Manila. At least that happened a few weeks ago. And we're becoming a little more interlaced. And I think that too holds some prospect of helping us become more willing to treat someone in Bangladesh as a neighbor. This is all wishful and whatever, but I think it's necessary.
I think it's true.
Yeah.
Well said. Are there more questions?
One more?
Okay.
My question is that in that graph that you had showing the polar cap shrinking, the sea, the colorful one, the sea around it appears to be rotating and not in the direction I would expect either. Do you have any idea why that is?
Oh, that was just a dynamic of the ice. The ice patterns move. The ice up there it's like a big circulatory system. There's ocean water coming in from the Pacific through between Alaska and Russia, and that causes a big current, a gyre in part of the Arctic Ocean that makes it all move, literally. So that ice cap that looks kind of like just a cap on a map, it's just this white surface, is all dynamic. And it's like a Scrabble board. And each Scrabble tile is bigger than this building and floating on the ocean and moving around. So it's a very dynamic system. In fact, I had the simulations. I could even, if you email me, I can send you simulations that show just how amazing it is. And some sea ice gets flushed out past Greenland periodically. It builds up in the Arctic, and then it's like someone hits the flush on a toilet, and it all kind of surges out past Greenland. It's amazing. It's a very dynamic system.
Andrew Revkin, thank you enormously for this book. I wanted to give everybody time to think of buying this book and Andrew to sign them, but I just want to thank you for your work and a terrifically interesting presentation. I just want to make note, one of the interesting things about the book is that there's a good deal of Andrew's own story in there, including his father, who was in the Merchant Marine, and his sons, to whom the book is dedicated. What do you tell your kids about it? And that's my last question.
Well, I think each of us should devote a little part of each day, or at least each week, or at least each month, or at least each year, to thinking outside the now. Mm-hmm. And as you grow older and as you become a parent or a grandparent, I think you do more of that because you're thinking definitely much more about then, the next now, which is your children's now. So I just feel that's why I'm doing this stuff. I do this. This is my contribution to them, and I think they understand it. They're very grumpy when I go away on these trips, actually, but I think they'll appreciate it later.
Thank you for putting yourself in your work and in the Museum of Science.
Thank you. Thanks for coming.
Thank you, Andy and Chris, and thank everybody for coming. We hope you'll join us as we continue to explore this issue in February and March. And outside, you can purchase a copy of the book, and Andy will sign for you. So join us outside.
Thanks again.